Hi everyone, welcome back to another episode of ThatOneSecGuy's podcast. Friends, today we are having with us a very esteemed guest who is going to be delivering a lot of insights regarding the entire landscape of security in smart contracts section, right? So we welcome Shashank to the show. Hi Shashank, how are you?
Hey Harshil, hi everyone. Nice meeting you. Thank you so much for the invitation here.
Lovely. So, friends, for a lot of you who might not know about what Shashank is doing, Shashank is building some really cool products to be able to secure the entire of Web3 landscape. And he runs a company called CredShields. So, Shashank, if you would like to introduce yourself.
Sure. I started my journey as a bug bounty hunter itself way back in 2013. I found my first bug in Google. It was a cross-site shifting bug, and I got listed in Google Security Hall of Fame. And that time I was just 15 years old, and it's like I got
Wow.
pretty excited about this journey that okay, it's like you can actually find bugs and then get paid from it. And I pretty much did bug bounty most of my teenage life as well as college life. I found bugs in Google, Facebook, Microsoft, Twitter, almost every it's like responsible disclosure program. I was there. Few of my best works were I found 3.0 days in iOS 10.3, for
Wow.
which I got CV assigned by Apple itself. That was in 2017 or 18, I guess, while I was in college second year.
Mhm.
My corporate experience, I worked with a few companies, first being Deriv, which was a derivative trading company based out of Malaysia. That was
Mhm.
something I was working while I was doing my college from first year to fourth year of my college. Then after college, I joined HackerOne as a security analyst. And
Mhm.
I was also working as a pen tester for Cobalt. I've done almost 200 plus pen tests with Cobalt. And
Wow.
then while I was, working at HackerOne, my interest, started getting into Web3 security, because I had spent almost a decade in Web2 security, and this was something intriguing. I've been using cryptos for a very long time to receive my bounties or something like that.
Right.
And then the concept of Ethereum came in, and people started writing programs on blockchain, and I was curious, like how this works. And my curiosity rose when smart contracts started getting hacked. You read the news and it's like, okay, 10 million gone, 20 million gone. I
Yep.
was like, what's going on? So I taught myself Solidity, and then I started looking for bugs, just to teach myself. And I found two critical bugs in Avalanche,
Okay.
which is one of the top 10 blockchains. And that's where I got a job offer to work at Avalanche. I worked there. My work was very short lived there. I worked for, I think, 4 or 5 months, I guess. Um, and that's where it's like I realized that okay, this industry needs to scale. And
Mhm.
I have seen the development of automation tools in Web2 industry. We have tools for everything, be it it's like cloud security, mobile application security, web application security. We have Web2 tools everywhere,
Right.
but nobody was building much for Web3. And
Mhm.
there were not enough detectors, there were not even knowledge base. And that's where I decided to start this company called CredShields.
Mhm.
It's like cred means credibility, shields means shield. We just came up with this name, and then
Right.
we started our product called Solidity Scan. Self-explanatory. Solidity is a programming language for smart contracts, and Scan is to perform scan.
Mhm.
We started as a team of three. Now we are a team of 22, and in the industry right now, we have the highest number of detectors. We have, it's like researched and written over 225, detectors right now, which is highest in the industry.
Mhm.
And this is something we all did, working together as a team, researching on, it's like hacks, decoding hacks. So if you go to our blog, you'll see we have done almost 150 blog posts about hacks which has happened, for smart contracts. And using those knowledge base, we started building detectors, and that's how far we have come from.
Wow, that's a great journey actually. And I think it's not just a Web3 landscape, right? You've spent a substantial amount of time doing same amount of things in Web2 as well. So I mean, it's going to be very interesting because I have certain questions. Being a very script kiddie in the Web3 zone, I'm going to take a lot of references from Web2 security landscape and ask you how this works in Web3, right? So, thank you so much, firstly, Shashank, for contributing and providing your insights. Let's get started, right? So, maybe to kind of cater to the wider audience and people who are listening and tuning in for the first time into the smart contract security, if we can do some context setting by first explaining certain terminologies, right? So let's get started by what exactly is a blockchain.
So, blockchain is a concept, and it's like there were it's like many cryptocurrencies which came on top of that.
Hmm.
It's very sad that it's like the hyper market, the financial market of cryptocurrencies overtake the beautiful tech behind it. And then
Hmm.
if you understand it, it's a very interesting technology. So Bitcoin was built over the concept of blockchain, where it was it's a peer-to-peer currency, where the price is determined by the people itself. It's like the price is determined basically who is willing to buy or sell at what price.
Hmm.
So how blockchain works is it's like a public ledger. If I have to explain in it's like in a very simple term, if you go to a bank, it's like suppose I have 100 rupees, and Harshil has 100 rupees. So we are both Harshil and Shashank, and we register, we submit 100
Hmm.
rupees there. Now I know I have 100 rupees. Harshil knows he has 100 rupees, and we don't know how much the bank has, right? And
Hmm.
that has been a financial problem for the world, where people are printing money, and it's like it has been a problem. So the problem here is that banks are centralized, and
Hmm.
we don't know if it's like the bank gave a 200 rupee bank loan, and now they're left with nothing. So when I go and withdraw there, I literally have nothing, and I'm not aware of it unless I withdraw it.
Hmm.
So that was one of the bigger problem. There was no transparency, and with blockchain, what happens is like if I explain in very simple terms, now banks don't. There is no central authority like banks. For
Hmm.
example, it's me and Harshil, and we both have a ledger which mentions I have 100 rupees and Harshil has 100 rupees. Now, if we scale it up, if there are 100 people and transactions are going on, everything gets mentioned in the ledger.
Hmm.
So if you see why so the blockchain has blocks, and each blocks has transactions stored on it. So when you store a node, which is called as it's like hosting a node, when you store a node, it's huge data.
Hmm.
The reason why it is a huge data is because it stores from transaction one, which happened in 2008, till date, like till now, whatever transactions is happening. So
Okay.
how this happens, like if I explain in very simple terms, there are 100 people, and every one of them have the same ledger, and every transaction is being recorded and being updated to everyone.
Hmm.
So what happens is, like, for example, if I go malicious and if I say that, okay, the transaction between me and Harshil happened where Harshil transferred me 100 rupees, but
Hmm.
he didn't do that, and I update my ledger, but then there are 99 other people who will prove me wrong.
Right. Right.
So the power becomes decentralized, and that's how blockchain works. But
Got it.
but the thing was, way back, it's like before Ethereum came into picture, blockchain was committed to a very simple transaction of yes and no. It's like a transaction has happened or not happened. It was not programmable. The
Hmm.
programming was very limited to a yes or no statement. But then, it's like Vitalik came with a very beautiful idea. Why not, it's like make programmable blockchains, so people
Right.
can actually host codes on blockchain, and that's where the entire concept of smart contracts and all came into picture.
Okay. Okay. So essentially, if we look at it in one angle, blockchain has, there are multiple types of blockchains, Bitcoin being one, Ethereum being one. So these are these very famous blockchains. And Bitcoin is something that works in a very Boolean logic way, which,
Yes,
yes, there's a true or false on a transaction. And Ethereum is something that can host persistent scripts, if we can say, right?
exactly,
And
exactly.
this is kind of the term persistent scripts came from a tweet that I saw. I think it was Vitalik. I'm not sure, but he said he regrets calling smart contracts as smart contracts because it lost the magic of its term. Rather, it should have been something more boring like persistent scripts, because that's all it is really. So great. I understood what a blockchain is, why we have these different types of blockchain, Bitcoin, Ethereum, etc. And now, if we can just kind of look at smart contracts in a little more depth, I know that these smart contracts can be developed using multiple languages. How similarly, like Web2, right? We have Django, we have Laravel, and all of those things. Similarly, we have frameworks and languages in the Web3 to be able to develop these smart contracts. So, are there any famous programming languages or frameworks that are used to do these developments?
Yeah. Let me explain what smart contracts actually are.
Mm.
So, so there is a blockchain which stores all the data and everything. You know, it has transactions, it has codes, it has everything, right? Now, to interact with a blockchain, you need a programming language, and that's where it's like the smart contracts came into picture.
Mm.
These are the programs which interact with the blockchain and with us. You know, it helps us interact with the blockchain and does stuff on the blockchain itself, maybe it reading or writing. It's very similar to it's like I read in the Ethereum yellow book, I guess. It's a very beautiful line stating that Ethereum is a world's computer. You know, it's
Yes, yes.
everyone's computer, and everyone is writing their codes and is doing things.
Mm.
And that's where you pay gas fees. Like for every contract, you pay a gas fees because you are using the network, so you pay to the network, and it's like completely decentralized.
Mm.
So if you talk about programming languages, yes, to it's like work on a blockchain, you need to know it's like certain programming languages. The most popular one being Solidity.
Mm.
Then for Solana contracts, it's mostly written in Rust, and then near as well Rust. Parity Inc. is there for Polkadot.
Mm.
But most of the EVM compatible chains, they are all written in Solidity. Maximum of the blockchains are EVM compatible. So Solidity is much popular there. There is also a programming language called Viper, which is
Yes.
it's very simpler way, but I mean it's not as popular as Solidity. But yes, that's few of them.
Okay, okay. So, you spoke about why, one of these programming languages is very famous, but I wanted to understand why do you think Solidity is so famous and how is it exactly different in comparison to our Web2 object-oriented programming languages like C++ or Java, right? Because if we can spend some time understanding this at a later point of the episode, I want to kind of get into certain code level vulnerabilities, and this will then tie back that context for the audience.
No, actually, Solidity is not very different. If you read Solidity, it is an object-oriented programming language. It's very similar to, it's like object-oriented programming language. It's
Mm-hmm.
just that to cater to the needs of blockchain, certain things have been introduced. But if it's like if you sit and learn programming languages, basic concept is still the same. You inherit contracts. It's like so. Basically, contract is a class. It's like if you have done OOPS, if you know the OOPS concept, the contracts are classes, and then you can inherit then you can write functions, you can define variables, and
Mm.
then there are other things like like message.value, msg.value, msg.sender, tx.origin. These are some external extra keywords which have been implemented that is very specific to the blockchain because again it's
Mm.
interacting with something very different.
Okay.
But learning Solidity is very easy. I mean, it's if you know any it's like object-oriented programming language, you'll definitely learn this. It's not very
Okay.
hard.
Okay. So we have same kind of techniques like object instantiation and all of those object-oriented principles as well, right? Like
Yeah.
encapsulation, polymorphism. It's almost
Yep.
everything is the
Yeah.
same.
Exactly.
Okay.
Polymorphism is there in Solidity. Inheritance is there. Everything is
Okay.
there. Modifiers are there.
Okay, okay, great. So now coming to a little bit of the security aspects of this, right? So I understood what a blockchain is, I understood what smart contracts are and how they are built using Solidity and what Solidity is at least to a certain level. Now, when we talk about vulnerabilities in smart contracts, do we have certain vulnerabilities that can be mapped to Web2 vulnerabilities? For example, the broken access control is a big one in the Web2 landscape. So,
Yep.
is broken access control a security concern even in the Web3 landscape? And do you have any, case studies regarding these?
Yeah, exactly. I mean, you picked on a very good point. Was there are actually access control vulnerabilities in smart contracts, and it's like I can actually show you a demo as well. It's a very simple demo because it's very much related with Web2 vulnerabilities.
Sure.
You'll understand that. So let me just search one of the blogs we wrote. I'll
Hmm.
share my screen. Let me just find the blogs.
Sure, sure.
Um, uh, my screen is visible, right?
Yes, that's visible.
So this is one of the hack analysis we did. It's
Hmm.
like on our while we were doing research. So there was a company called ShadowFi,
Mm-hmm.
and if you see, it's like they got hacked by it's like someone withdrew the entire balance. So what we did was, it's like our friend who was looking for help, they
Hmm.
gave us this transaction address of
Mm-hmm.
a hacker. So this is technically, so I'll explain what is this as well. So BSC scan is basically an explorer for Binance. So this hack happened on Binance chain.
Okay.
Similarly, we have Etherscan, Blockscout, etc., where you can visualize transactions.
Mm.
So so if you see, what is happening here. If you see, it's like the hacker bought, it's like ShadowFi tokens, like 0.57, 0.9 tokens. So basically, bought like 9.5 ShadowFi tokens for
Mm-hmm.
a worth of $0.58. So you can
Okay.
see wrapped BNP is something similar to what you can say as Ethereum. Okay, so
Okay.
Ethereum, and then you have BNB. So BNB chain has BNB, Ethereum chain has Ethereum.
Mm.
So he used, BNB to buy some ShadowFi tokens. Okay,
Mm.
and then you can see something happened here. This is what is interesting. Um, the contract sent almost 10 million tokens to null address. So there is something called null address in blockchain, where nobody has a control over this address. Like nobody can access this address. So it is used as a method to burn tokens. For example, what happens in blockchain is everything is immutable. You cannot
Mm.
destroy something directly.
Correct.
So if you want to it's like if you want to reduce the supply of tokens, you send it to a null address showing
Mm.
to a proof that this is not owned by anyone, so this has been burnt, like the supply has been
Reduced.
reduced.
Right.
So if you see in a very fraction of seconds, it's like what happened was the contract sent 10 million tokens, almost burning the entire supply. So
Okay.
what happened was, it's like the price got inflated, right?
Mm. Mm.
So it's like now this 9 ShadowFi token was worth more than because the supply went down. Okay,
Mm.
so you can see ultimately the guy, the hacker, whoever he she was, they managed to sell it, the 8.5 and 5 tokens, almost 9 tokens,
Mm-hmm.
for almost $600,000, more than $500,000. So
Wow.
if we summarize this, what happened was the hacker bought, the supply was 10 million, and
Mm-hmm.
so the price of the token was very less. Okay,
Mm.
so for almost 50 cents, the hacker bought almost like 9 tokens.
Mm-hmm.
Then something happened, which this is what the vulnerability is about. I'll come back to that later.
Sure.
So something happened here, and suddenly the supply went to be negligible. So
Mm.
almost 10 million of the supply was gone.
Mm.
Now these 9 tokens were more valuable, so it had a higher price,
Due
and
to a
the hack,
reduced supply.
yeah, due to the reduced supply.
Mm.
So now it was more, it's like precious, and the hacker sold it for almost 600K, which is more than half a million,
Of
and then
course.
got away
Mm.
with it. So while we were doing research, this is something what it's like made us suspicious that why 10 million tokens were gone. So
Okay.
it's like what we saw in the code was, you see
Mm-hmm.
the function burn function. So
Mm-hmm.
there was a function to burn tokens. Okay,
Mm-hmm.
and it was a public function, and it did not have any modifier, like if it can only be called by the admins, or it can be called by a certain address. There was no validation on this burn function, so this one burn function could be called by anyone. So what the
Okay.
hacker did was basically he triggered a burn, and then he took away all the money. So
Okay.
ideally the
Okay.
fix would have been, it's like to have a check, like, okay, only this address, the admin address, like require statement stating that, okay, only this person can, or only this address interacting the smart contract can burn, who is supposed to be the
Mm.
admin, not anyone else. So this is one of the bug. uh,
Right.
Similar to that was here as well. It's like again, this was being detected by, it's like our own our tool as well. So if you see,
Mm-hmm.
this burn function, okay, this is the code here. I can show you this one. So if you see the code, line number is 1348. Let's go to 1348. 1348. So yeah, you can see
Yes.
again the same mistake. You can see the burn function is public. So what
Correct. Correct.
any external user can do is, it's like they can call this function, burn the supply,
Mm.
inflate the price, and then make more money out of it's like their tokens. And yeah, I mean, it's like this is one class of, it's like if you see our tool as well, we
Mm.
flag it as incorrect access control, which is very similar to what we call in, it's like for
Broken
RBAC
access
related,
control.
yeah,
Yeah.
broken access control. That's something we talk about in, it's like in Web 2 as well. So
Right.
it's very similar to that.
Wow. Awesome. So this is very cool. And if I can actually go back to the same thing, right? So you said something called a null address. Now, is
Yeah.
this part of every chain, or was this specific to this specific smart contract? If you can just give
So
some more insights.
yeah, so every chain has a null address. For
Mm.
example, BNB has something called so mostly it is a zero, it's called as a zero address. So,
Hmm.
it will start with OX0. It's written as OX0.
Hmm.
Or Binance has a Binance calls it OX0000. At the end, it will be DED, dead. And
Hmm.
Ethereum has standard 0x00000. So that is one of the commonly known standard that zero address is not controlled by anyone.
Hmm.
So zero address is where, it's like, it's very interesting. What you should do is like go to Etherscan or Binance Scan and open the null address, and you will
Okay.
see it's the richest account you will ever see in your life because all the burnt tokens are there.
Burnt
So
tokens are there. Okay.
yeah,
And these burnt tokens have no ownership basically because they are in
exactly.
the null address. Okay.
Yeah,
Okay.
exactly.
Brilliant. And this was a demonstration of access control vulnerability, right?
Yeah.
Awesome. Now, this I think definitely is a financial impact. But are there instances of vulnerabilities being exploited to create a reputational impact? And the reason I'm asking this is because reputational impact also at the end of the day falls back to financial impact, but it really manipulates the trader's mindset to be buying these tokens, right? So are there any other such case studies?
Yeah, I mean, it's like we have seen many cases like when we do services, it's like when we do audits as well. So our company does both of things. We have a tool which does automation, and we also do services as well where we do manual pen testing or audit of a smart contract. And we see multiple cases like that.
Hmm.
So it's like we have severities in web where same we have severities of vulnerabilities in smart contracts as well.
Hmm.
So of course, since here the biggest impact always goes into financial loss, right? So those are mostly critical vulnerabilities. But then it's like you'll see different kind of access control vulnerabilities as well. It's like where the impact is low, but it does harm the it's like the business logic of the application. Like for
Okay.
example, one I clearly remember was there was a vesting contract. Like the company was going for a token launch, and they had this vesting contract where their investors will get token vested at a certain period of time. Okay.
Hmm. Hmm.
And they had a feature where it's like they can blacklist tokens, addresses. For
Right.
example, if they find something is malicious, or if something happened with the investor, if they want to store hold funds,
Hmm.
they created a blacklist function. And
Right.
again, it's like it had incorrect access. It has it, although it could not be called by everyone, but
Hmm.
someone of the non-admin class which had some other different privileges which should not have access to those functions.
Hmm.
Those restrictions were not in place. So you will come across a lot of business logic vulnerabilities as well.
Okay.
And I mean, let's not just limit ourselves to smart contract vulnerabilities. It's like vulnerabilities can happen on the blockchain itself.
Hmm. Hmm.
For example, I would love to talk about my own bug which got me a job at Avalanche.
Okay.
So it's like so I was just running their Avalanche node on a local network, their testnet, and trying to understand their RPC calls.
Hmm.
So I was making all the RPC calls, and then I found one endpoint which was not supposed to go on the prod, I guess. It what it did was it generated a profile something
Hmm.
on the server. So I realized that okay, it's like I went through the source code, and then I realized there is it's like you can name whatever the file you want, and
Hmm.
the file will be generated on the server, and you can it's like you can create it as a log. It was something for logging or some purpose. Okay.
Hmm.
And what I realized was the file name was not having input validation properly. Okay.
Okay.
So
Okay.
what I could do was I could create any file name. I can make it. It by default it was called profile something. I don't remember exactly, but I could make it Shashank whatever.
Okay.
Uh, then my first it's like my experience from Web 2 triggered me like if can I traverse the path. So I started adding dot dot slash dot dot
Hmm.
slash. Okay.
Hmm.
And I realized I had a like I didn't do in the production server. I had my own node server. Like I had a blockchain copy in my it's like in my VM, and
Hmm.
I could see how the servers was working. So I saw that okay, I actually could create the file on different
Hmm.
location. So so now out of curiosity, like how I can increase the severity of the bug, right?
Hmm. Hmm.
So I started looking for sensitive files which I can overwrite, and then I figured out there is a keychain file. So every blockchain will have a keychain file, which is for authentication. That's, because without that, it will not sync at all.
Of course.
That's
Yeah.
what keeps the server running. This is a keychain
Yes.
file. So if you corrupt the keychain file, the chain will stop syncing because it doesn't have any credentials anymore to authenticate or do anything. And I did what I figured out the path, and I called the path, and then I realized that okay, it's like I can actually corrupt the keychain file, and the chain will halt. I reported to them, they fixed it. The bug is still there in their Avalanche Go, it's like
Archives.
PR. Yeah, I filed it as a, it's like not a PR. I filed it as an issue under GitHub. It's still there. They fixed it that time itself and gave me a bounty, and that's where I was offered a job there. So sometimes, it's like you can even find not only bugs in smart contracts, but it's there in the blockchain itself.
In the blockchain itself.
So yeah.
Okay. Very interesting, Shashank. I think some great case studies, and it is very nice to actually see that level of financial impact happening because of the exploitation of these vulnerabilities. So thank you for that. Now, this brought me to a question that I think a lot of these smart contract vulnerabilities, even that Solidity scan identifies and all of these other code scanners are identifying, right? These are code level vulnerabilities. Now, in Web 2, we have certain secure coding guidelines, which maybe organizations like OWASP and all develop. Are there similar kind of secure coding guidelines in the Web 3 landscape for people who code in Solidity and all these programming languages?
Yes. So, I mean, see, to be very honest, this industry is very new, and yes, there are not much standards right now, but people are building it. Actually, I am one of them.
Okay.
So, right now, it's like OWASP has released its OWASP top 10. It's like, let me show you OWASP top 10 smart contracts. The screen is visible, right? So you can
Yes,
see,
now
it's
it's
like
visible.
now, it's like I'm actually leading this project. With I actually realized like I have immense, knowledge base while I was building the product, and there were
Of course.
no standards. So I started, it's like contributing here at the OWASP Smart Contract Top 10, and it's like this is one of the vulnerabilities we talked about, right? Access control vulnerabilities.
Right.
It's like the top 10 has been determined, and it's like furthermore, it's like what do you say? Furthermore, standards will come into picture. The thing is, that this industry is still very raw. A lot of new frameworks are also coming, so it's
Right.
not very much organized. But of course, in the future, it will come.
Okay.
So and what we have also done is, it's like if you go to our Solidity scan, we also, it's like we started, there was something called SWC registry before. SWC registry. Initially when it's like OWASP top 10 was not there. This was one of the it's like standard,
References.
but yeah, references. But again, this was while we were doing research, we realized that we already outclassed them. Like we found more attack vectors than what it is mentioned.
Wow.
So it's a good thing to start with, but yes, this also needs a lot of work to be updated. So
Okay.
that's what we are trying with OWASP right now to create proper standards and everything.
And
And
this OWASP smart contract top 10, is it already out, or is this something that is private that you're showing?
no, this is public. This is public.
This is
This
public.
is a
Okay.
public. Yeah, this is on OWASP. And if you go to the OWASP smart, oh, you can just actually go from here.
Sure. Sure.
It's a public GitHub repository, and it's like you can see it's like I made a commit 5 days back.
Wow.
So
Okay.
yeah, I mean it's like we are adding more examples and more writing better. So recently we updated all the descriptions in a better manner, and then if you see access control vulnerabilities, we started adding it's like this is one of the example which I showed, right? So this is something we used here itself, and we started adding remediations and sample hacks and impacts. So we are improving it. The top 10 is very much improved right now, but yes, we'll continue doing it as we gain more information on this field.
Awesome. Okay. Got it. Lovely. So we have a
Yeah,
lot of these tools, and correct me if I'm wrong, but my understanding is that Solidity Scan works like how a Qualys or an SS works for Web 2. Is that
exactly.
correct? Right. Okay.
Correct.
Now, is there a DevOps or a DevSecOps sort of a process for the development of Web 3 based contracts where products like Solidity Scan can fit into the build pipelines?
So that is exactly what we did. We focused more towards, the enterprises and, the developer teams,
Hmm.
the tool existing in the markets where, it's like much more for individual tools. So if you, it's like if you see Solidity scan, let me just show you once.
Mm-hmm.
Let me log in so I can give you a small, it's like insight how it works, a very quick insight how it works.
Sure.
So for example, let me share my screen. So what we did was, not only just we didn't just focus on scanning. So if you see,
Mm-hmm.
it's like how it works is like you can add a project. So
Okay.
if you haven't made it your code public, it's still in GitHub or GitLab or Bitbucket in a public or private repository, you can just integrate and it's like perform a scan of your smart contracts.
Like
Apart from
Slick.
that, what we yes, I mean, yes, exactly.
Okay.
And I'll come back to those features as well. And then what we also did was we did an integration with all, it's like all explorers.
Mm.
So
Mm.
what happens is, it's like, for example, the explorer we were talking about, there is one explorer called Block Scout. It's a very famous one. So what we did was we did a bilateral integration with them where, it's
Mm-hmm.
like anyone who verifies their smart contract, for example, take this contract. Now,
Mm-hmm.
this contract is verified. This is one of a very common thing in, it's like blockchain is that, no, smart contract is that people
Mm.
won't interact with a smart contract if the code is not public. That's what we talk about transparency and, and other things like, so people don't interact with a smart contract, which is a binary. People want to see the codes and make sure that it matches with it's the same as the binary one, and they can
Mm.
read the code so that they can figure out something fishy is there or not. It's like the code is clear, it's transparent.
Right.
So what we did was we did an integration with them. It's like it's a bilateral integration. You can see, it's like our score here as well. Or
Mm.
what you can do is like if you have a smart contract, all you can do is like you can select, it's like for example, this is on Ethereum. So you can select Ethereum. The platform is by Block Scout, and you can, if you enter your smart contract address, this will perform a scan for you. It will perform a scan. It will give you a result.
Wow.
And
And
for
this is very quick
example,
as well.
uh, yeah, it's very quick.
Mm.
So, for example, it's like if we talk about, let me just open someone safe, some test which we are doing. Okay, so for example,
Mm-hmm.
if you take this, so what it does is it gives you score, and your score improves as you fix the vulnerability. Okay,
Right.
and
Right.
then here it gives you, it's like all the details of the vulnerability, like incorrect access control, and then you can
Mm.
see the vulnerability description, the suggested fix, like how you should fix the vulnerability, and these all goes from critical, high, medium, low, informative, and gas. And
Mm.
this is very
Mm.
interesting. This is not there in Web 2. So in Web 2,
Right.
what happens is, like if you write a bad code, okay, very non-optimized code, the max it will happen is, the website will be slow, right?
Right.
But here, what happens is like when you are using the Ethereum network or any blockchain,
Mm.
Binance network or Avalanche network. So how this works is, it's like, so we also give gas optimization techniques as well. It's like we tell you how you can, it's like, so for example, it's very simple, in very simple words. This was imported, this code was imported, but then
Mm.
it is not being used is not being called inside the contract anywhere. So it's an
Correct.
unused, like it's unnecessary code. It's an extra code. And again,
Okay.
when you're compiling extra codes or making, it's like unnecessary things, yeah,
Mm.
you end up paying more gas fees. So
Okay. Okay.
these things are important, and this is we find everything like from vulnerabilities to code optimizations. And then, it's like we give you the fixes, and, it's like you can take actions as well. For example, maybe for example, let's talk about events. It's like you don't care, you don't want to care about low priority vulnerabilities. You can
Mm.
add it as won't fix and say like, I don't care, whatever. Okay.
Mm.
And then the best part comes is what we have done is like we help you generate an audit report at a click of a button. So once you have addressed all the vulnerabilities, you can actually
Mm.
go and see a very nice, beautiful audit report. It will come with executive table of content, executive summary, the
Wow.
vulnerability status. Like, it says like, okay, this bug was marked as won't fix, that, people don't want to fix it. It will show the entire report. It's basically an audit report, like we have in pen testing in Web 2, right? We
Right.
generate
Right.
pen test reports. So we have automated this entire thing. And for, it's like when you were talking about CI/CD pipeline. So if you add a GitHub application, what it does is like, you will have an option later on to enable, GitHub Actions. So every time you make a commit or you make any changes to the code, an automatic scan will be triggered here. And if you integrate, it's like if you integrate Slack as well, it will give you an alert on your Slack channel that, okay, this was a scan has happened. Yeah, these are the new vulnerabilities. And there is even a scan history for everything, like how your code is improving, what new
Right.
vulnerabilities were found. So everything comes into picture. So
Awesome.
this is what we have exactly built.
Awesome.
The use of blockchain technology is exponentially rising faster than ever before. But with that kind of growth comes a ton of security complexities, with the bad actors always ready for their next move. Due to this, millions of dollars are lost every month in smart contract hacks. And audits are a costly affair in terms of both money and time. Meet Solidity Scan, your personal auditor, which eliminates the complexity and gives you vulnerability insights at the click of a button. Solidity Scan is built for anyone and everyone interacting with a smart contract. So how does it work? By automatically ingesting your Solidity code from GitHub, known block explorers, or from your uploaded files. Optimize your code, fix the detected vulnerabilities, and rescan your code to watch your security posture evolve over time. Integrate with your favorite applications and take control over your security assessment, leveraging numerous action items right from your dashboard. Use the advanced automated reporting functionality to generate and publish your audit report in a few minutes and share it with your team, community, and stakeholders. Solidity Scan is simplifying the way we perceive security. What took months now takes days. What took multiple processes and manual intervention is now fully automated. So you can focus on the things you love most, creating new products and growing your organization. This is the future of smart contract security.
These are actually some crazy times, Shashank. I mean, we are shifting left in the Web3 landscape, which is, I don't think a lot of people might have thought this a decade back. So some amazing times, and, kudos to people like you who are at the top of these kind of emerging technologies. So thank you very much for that. I have a last question. Of course, it's 2024, so we need to talk about AI, right? And I wanted to kind of ask at CredShields, how is the adaptation of AI being integrated into the product development, or are we going to see any functionalities based on LLM that is going to be integrated in future products?
That's a very interesting thing, is because it is in our pipeline. Our next prod release is going to have a very great feature. So you might have observed the remediation feature, right? Where we say that how you fix this vulnerability, and we realize that it's like a lot of developers are not very proficient with it's like understanding what the right fix may be. So we have been closely working on AI, because again, it's very hard to implement here. The reason being that is it's a very subset. The data is not very trained here. We don't have enough knowledge base of that. But we are doing data labeling for creating our own it's like data models where we can do AI related it's like vulnerability findings. So right now it's like we have already enabled AI on a lot of it's like a lot of our detectors. For example, let's talk about access control itself. So again,
Okay.
it's like you have to figure out it's like there are pretty obvious like which functions need to have access control. Obviously, a burn function will never be public, but then there can be functionalities which it's very hard to find in an algorithmic way that it is sensitive enough to be an admin function or not, right? So what we did was it's like we started feeding context to the AI, maybe passing documentation or it's like something like that, and to see it's like if it can reduce false positives, because it will flag it's like as per it wishes that okay as per its algorithm that okay these are access control, but then it's like as an automation tool it does find false positives as well, and that's where you reduce false positives. So we are still working on that, and it's like few of the models have reduced false positives because we started doing AI queries on that. Especially it's like how we are implementing is that it's like you have a search going on for certain steps to find a vulnerability, right? And we realized that on step 3, our false positive rates are higher. So we are adding a prompt, LLM prompt there to, make it much better, less false positive, make it false positive resistant. And what
Okay.
we have made it work is, the remediation part, which I was talking about. It's again in staging right now. We are going to release in maybe next week or maybe next to next week.
Okay.
What we are doing is now people will have a feature where they see a vulnerability. So again you might have seen the vulnerability is there on the top, highlighting the code base which is vulnerable, right? And then you
Right.
have description and remediation. Now you have a AI patch assistant. So when you click on that, it will actually generate you the updated code. So for
Oh,
example,
wow.
if there was an RBAC, so for example, a modifier was missing in an access control vulnerability, it will tell you that, okay, you can import OpenZeppelin's, only owner modifier, and then add only owner modifier to that, or maybe add a require statement with, the contract owner as a check. Or for example, for reentrancy vulnerabilities, it can give you a suggestion that, you can have reentrancy guards in place, or you can have check effective patterns in place. So that's what we are working on right now, and that will be released on the product very soon.
Awesome. So I don't want to take more of your sauce, right? Because we are going to be seeing some cool things come out anyway in the near future. So we'll await that. And congratulations on the new features as well. So Shashank, it's been great to be able to get these insights from you. My one last question, and which is not a very technical oriented question, but a question that I get a lot, is that from a trader's point of view, right? There are a lot of these tokens that are coming into the market, and some of them are just scams, right? Like some tokens, they are just working on the pump and dump concept, and some of them are working on Ponzi pyramid schemes. So, is there a way from a trader's perspective that they can be secure? Or they can do some due diligence before trying and buying and investing in a specific token.
Actually, this was asked to us by a lot of our own users. If you see our product, we cater the needs of developers. But then there are lots of people who are making trades, or and then we actually saw it as a problem statement. And I'll show you what we have built. It's very interesting. So, let me share my screen. This one is interesting. I'm glad you asked. So, this was in beta for a very long time, and
Okay.
now we actually and this is again free to use. I mean, we made it free for everyone. So if you see right now, just let it load for a second. So for example, what we did was we made 2 classifications. One is security score, which mostly talks about vulnerabilities, right? And we added something called as threat scores. So I'll explain you. It's a very beautiful concept. All it does is what we do is we have checks for vulnerabilities, right? And
Right.
then we were doing some studies of rug pulls happening, people getting scammed. So what we did was what we understood was, although this blockchain concept is great, where the source code are public and everything is visible. But the problem is not everyone is technical enough to go through the source code to understand what is fishy, right?
Right.
So what we did was we take the same concept, we take the source code, and then we started giving it, we started building green and red flags. For example, if the source code is verified or not, it's using latest version. If there is a presence of burn function. So example, if there is a presence of burn function, although it is secure, being, handled by admin, correct? But then
Right.
there is a problem here that, the admin has the power to burn the
Correct.
supply, or, mint the
Yes.
supply. Basically, an admin can manipulate the supply, right? And that impacts the token pricing and everything, right? So, if owners can blacklist users or not, okay, if they can pause the contract, if they can destroy the contract. This is one which is very interesting is, if any owner has more than, if there is a contract and it has a token, and if that token supply of more than 5% is owned by certain, addresses, we flag it here. We show it that, okay, 3 of the addresses had 5% each. So, they are holding more than 5%. So maybe they can be manipulators or something like that.
Right.
Whitelisting,
Right.
hard-coded address, etc., etc. So we created 25 checklists. And I mean, like we don't. I mean, of course, it is not easy to say that this will be a rug pull or not. For example, let's talk about minting function itself. Yeah, that's a feature. Again, that's a
Right.
feature, but then it can be misused. So what we
Correct.
do is
Correct.
like we convert the code into a plain English language. Okay, we convert the code into plain English language for people to understand that okay, this is something you're going to deal with. We are not saying anything. We are just giving a threat score parameter that how many powerful functions are there with the admin, and you make your own judgment. So
Right. Right.
we and this got a lot of appreciation that people came to us and they said like, okay, you know what? Now I'm questioning the developer that why is this there? It's like
Right.
why do you have this power? Why can you adjust the fees?
Wow.
Why do you have no limit on fees adjustments? So people started questioning because now they understand and they can refer to. So
Correct.
this is something what we built. So mostly, it's like this was built under certain factors like we figured out that admin admin sometimes make a withdrawal because they have a withdraw function, or maybe they change the price, or maybe they drop the liquidity, or
Right.
maybe there are some suspicious functions like overpowered functions. So yes, I mean, it's like when as a trader, again, it's not a financial advice, but if you're trading with it, it's like make sure it's like you trust the project, the admin, don't go around the hype. There
Right.
is nothing such as being millionaires overnight. You may be lucky, but you have to understand most of the people are not. That's why these scams are prevalent, because someone else is making money, not you.
Correct.
And if you really want to make money, build something on blockchain. I think that is more rewarding and satisfactory than it's like looking into a token price whole day and night.
Absolutely. So, Shashank, by the way, this is mind-boggling, right? I want to just appreciate what you've done here and bringing in that change in the people's mindset to start questioning developers as to why this is there, why this is there. That is, I cannot kind of explain also, but it's a brilliant move towards secure world, right? So kudos that you are doing and creating such amazing products, and yeah, looking forward to a lot of these new developments in the near future.
Sure. Thank you so much.
Lovely. Great. So thank you so much, Shashank. That is it for this episode, and appreciate all of your insights. I think this episode is going to be a killer one. A lot of new things I personally also learned, having been doing smart contract based security for last 3-4 years now. And one of the things that I did actually not venture a lot into smart contracts in the early landscape was because I was not sure it was truly decentralized, because like you said in the last example, that we say decentralization as a USP of smart contracts and blockchains. However, all of these smart contracts have a central owner who can mint or burn the tokens based on the function. So that kind of made me skeptical in the very beginning. But thank you so much for your insights. And at that note, we will conclude this episode. Thank you so much, viewers, for tuning into this episode with Shashank and learning very brilliant insights from the smart contract security landscape. For more such videos on cybersecurity concepts and industry insights from such experts, please consider liking, sharing, and subscribing to the channel. And until the next episode, stay safe and stay curious. Thank you.
Thank you.